There's one final thing we can do with quadratics, and that is to do this with them, solve them. Quadratics, as we've seen so far, have all been expressions, but we could easily make a quadratic into an equation, i.e. something that's some algebra that's equal to something, by just giving it an equals a certain value. Something like, for example, x squared minus x minus 20 equals 0. And in putting that equals 0 on the end, we have made it into a particular thing. We have made it into an equation. This means that there is some number that when we square it and then take off a copy of it and then take off 20, we get exactly 0. And that is a perfectly reasonable thing. There's nothing wrong with that idea, and there's nothing wrong with asking us to solve it. Now, so far when we've looked at solving, there have been 3 different methods that we've looked at. The first was to think about the function machine, the idea of what happens to the x to build up to the answer, and then reversing it. Now, that's not going to work here as a method. That will only work for equations that look like this kind of thing. Or we've got a single number value of x. We've not got complicated stuff going on here. Looking at this one above, it wouldn't be clear which value of x to start on. Are we starting with the x squared? Are we starting with the x? And everything would get very, very tangled up. So we can't use our function machine. We can't use the scales. Similarly, the second way of solving stuff, we can't use those because the scales are only useful if we've got algebra on both sides of the equal sign. We haven't got that here. On this side there is just a single number, that number in this case being the number 0. So we can't use the scales either. Now actually we could use the third method for this. The third method, the method of trial and improvement. This is exactly the sort of equation that we could see in a trial and improvement question. Problem is, we're not going to do that here, and we can't do that here because the question hasn't told us to. For trial and improvement, we would only ever use it if the question said using the method of trial and improvement. Besides, even if we were going to, we don't yet know between which 2 numbers the solution will lie. So we need a new way of doing it. Now this fourth way of solving, this fourth and final way of solving, in fact, will only work and only need be used for quadratics like this. But it's not without its limitations, and it's actually nothing new, really. It's just a new application of something we've already seen, an extension to what we've already done. The first thing we have to bear in mind when we solve quadratics is that we can only solve quadratics, these type of equations, when they are equal to 0. Now I get that. I appreciate that that may seem a little artificial, because surely if this was the kind of thing that could come from a real life situation, if there was a real life problem that when we turned it into algebra, like we're going to do at some point, if we were to turn it into algebra and we were to get this perfectly reasonable expression out of it, what are the chances that that problem might equal 0? Well, probably very, very slim. It would happen sometimes, but most of the time it would probably equal some other number. This quadratic could well turn out to be equaling 5 or 17 or whatever. For reasons that are much too difficult and long to explain, we can only solve quadratics. It is only possible to solve quadratics when they are equal to 0. If you start with a quadratic that is not equal to 0, there are ways that you can muck about with it. You can change the question. You can start with a quadratic that isn't equal to 0, and you can muck about with it through a proper process and change it so that it is equal to 0. You have to cheat a little bit first and tweak the question, but it is possible to do. Now, we're never going to see that. We're only really likely to see quadratics that are equal to 0. So we need to be able to do the solving bit, not the getting it to the point where we can solve it bit. But it is worth appreciating that, yes, it is a little bit artificial, but to be able to solve it, we have to have it equal to 0, and it's not that big a deal in real life if it's not equal to 0, because there are ways to get it so that it does. We just don't need to know what they are or ever do them. The second thing we need to bear in mind is that we can only factorise, is that we can only solve a quadratic if we can factorise it. If it is possible to factorise the quadratic, then it is possible to solve. And this is why the solving part is just an add-on to stuff we've already done. Because really, the solving question is a factorising question with an extra couple of steps at the end. So if you can factorise, if you can get this quadratic into the 2 bracket form, then you can go on to do the solving of it. So we're going to have a look at this question then. We're going to start with this one. We're going to ask ourselves those 2 key questions first of all. First thing we're going to say, this question is asking us to solve the quadratic. Is it possible to solve? Well, first of all, we have to check whether it's equal to 0. If it isn't equal to 0, we can't do it. We need those extra tools to make it so that it is equal to 0. Actually, this one is equal to 0, so we're okay. It's already equal to 0, not a problem there. Second thing we have to say is, well, can we factorise it? Well, let's have a go. Let's ignore the equals 0. So our step 1 is going to be factorise the quadratic. Put it into the 2 brackets. Okay, so let's go. Step 1, factorise. Well, there are our 2 brackets ready to set up. We're ignoring the equals 0, remember. We're going to have an x here and an x here. We know that's going to be the case because we've just got a single x squared. So, we need 2 numbers. We need a number in each of the brackets. Those 2 numbers have to multiply together to make the 20, and they have to add or subtract to give us the number in front of the x, which in this case is 1. Those possibilities are 1 and 20, 2 and 10, or 4 and 5. The pair that we're going to have to go for, the only pair that we can use to get to 1, is this pair, the 4 and the 5. So I'm going to put the 4 in the first bracket, I'm going to put the 5 in the second one. We now have to work out the signs in the middle. Is going to be either a plus or a minus here, and a plus or a minus here. We can think cleverly about it. We can try and work out how we can use the 4 and the 5 to get to, in this case, minus 1. Noticing that there is in fact a 1 there, we just haven't necessarily written it in. The only way we can use 4 and 5 to get to minus 1 is to have it as a plus 4 and a minus 5, because 4 take away 5 is minus 1. So there is us having factorised the quadratic. Because it was possible to factorise and because it's already equal to 0, it is now possible to solve it. So I'm going to put the equals 0 back in. If this is equal to 0, then this must be equal to 0 as well, because they are the same thing expressed in 2 different ways. And the fact that this is equal to 0 is what makes it solvable, is what's important. X, here and here in fact, x is a particular number. By the time we get to the end of the question, we're hopefully going to know what that number is. But x stands for a particular number. Now that means that x plus 4 is also a number. It must be, because if x is a number, then add 4 to it, it's still a number. And again, if x is a number, then x take away 5 must be a number. Because if x is a number and we take away 5, a number take away 5 is still a number. So both of these brackets are numbers. We don't know what they are, but they are numbers. There is a symbol hidden in the middle here, and hidden in the middle there is the symbol times. There are 2 numbers that we are timesing together, and when we times those 2 numbers together, we get the number 0. There is only one possibility. When we times 2 numbers together to get 0, then one of those numbers has to be 0. The only way we can ever get 0 when we times 2 numbers together is if one of the numbers is 0. For example, 1 times 0 is 0, 2 times 0 is 0, 3 times 0 is 0. Or the other way around, 0 times 4 is 0, 0 times 5 is 0, 0 times 6 is 0, and so on. The only way we can ever reach 0 is if one of the numbers is, in fact, 0. The question is, which of these 2 numbers is going to be 0? Well, actually, we don't know. We don't know. We have 2 possible options. Option number 1 is that this first number is equal to 0. This first bracket, x plus 4, is 0. That's the first option. Or maybe it's the second option. Maybe it's the case that this second bracket is equal to 0. Let's see where it goes, let's see what happens. If it's the case that option 1, x plus 4 equals 0, something plus 4 gives us 0. What must the something be? Well, the something must be minus 4. Because minus 4 plus 4 gives us 0. Or maybe it's the case that option 2 is true. Maybe it's the case that the second number is 0. If it's the case that the second number is 0, then we've got the situation where something, take away 5, gives us 0. What must the something be? The something has to be 5. Because 5 take away 5 is 0. Now, in all other solving questions, we've got down to a single answer: x equals a particular number, or y equals a particular number, z equals a particular number, whatever. Here, we've got two possible options. Well, surely only one of them can be true. Surely x is either going to be minus 4 or x is going to be 5. Which one is the correct answer? Well, actually, without more information, we don't know. Because it kind of depends what x is. If x is the number of people, then this one will have to be true, because we can't have minus 4 people. If x is a length, then this one's going to have to be true, because we can't have minus 4 centimetres. If x is the amount of debt, then maybe this one's true, because x could be minus £4. As in, £4 less than 0. Without more information, we don't know. It might be just the case that x is a number less than 0, in which case this one has to be true. Or it might be a case that x is a number that's bigger than 0, in which case this one has to be the true one. But actually, do we have any information in this question to tell us anything extra about the number x? No, we don't. So the best we can do for this question, without more information, without more context, the best we can do is say that x equals, for our final answer, minus 4 or 5. It's not both. It's going to be one or the other. But without more information, we don't know which one. Solve. We're going to have another quadratic, and the quadratic we're going to have this time is going to be x squared minus 8x plus 12 equals 0. So we're going to check those two things. First thing we're going to check, is that quadratic equal to 0? In order to be able to solve it, we have to have it equal to 0. Well, that's okay. It's already equal to 0. If it wasn't, we might have to go through that step-by-step process of mucking about with it so that it is equal to 0. But actually, it's already done for us, as it always will be. So with this one, we don't have to worry about it. Second thing we have to do, we have to then check if it will factorise. If it factorises, we're sorted. We can go through that kind of solving process. If it doesn't, well, we can't solve it anyway. The fact that we're being asked to solve does suggest that it's probably going to factorise, but we're going to have to do that as a first step. When we're factorising then, it's one of these standard quadratics with the x squared term at the front, the number term at the end, and the x terms in the middle. So we can open our two brackets. We're going to have x there, and we're going to have x there. We need to look at the 12 first, because we need two numbers, one here and one here, that times together to make 12. They're also going to add or subtract to give us the 8, but we can look at the 12 as our first start point. 1 and 12, 2 and 6, 3 and 4. They are the possible pairings. There's only one of those pairings that will work to add or subtract to get to the 8, and that pairing is going to have to be the 2 and the 6, because 2 and 6 will add to get 8. So the 2 and the 6 are the numbers that are going to have to go in our brackets. We can then think about the signs. We need to reach not an 8, but a minus 8. And the only way we can do that would be to have a minus 2 and then a minus 6. Minus 2 take away 6 will indeed take us to minus 8. We could check that the multiplication still works. 2 times 6 is 12, but in fact it was minus 2 and minus 6. Minus 2 times minus 6, two minuses, two changes of direction. We're expecting to head up the number line and be a positive 12. 1 for the minus 2, 1 for the minus 6. We're still heading up the number line. It's still a positive 12, and everything has worked out nicely. So that is us having factorised that quadratic. We can stop ignoring the equals 0 now. We were ignoring it before because we were just factorising the quadratic. But now we can say that that is in fact equal to 0. They must both be equal to 0 because they are both the same thing written in two different forms. Now here, x is a number, so x minus 2 is also a number. It's a particular number, whatever x is. We're going to find out later. We're going to find out some possibilities. And if x is a number, then x take away 2 must also be a number. Similarly, if x is a number, then x take away 6 must also be a number. So we have two numbers here that are being times together, remembering that there is a times hidden in between those two brackets. We have two numbers that are being times together to give us 0. The only way we can have two numbers that times together to get 0, the only way, is if one of them is in fact 0. So either option 1, this first bracket is 0, and whatever number that is, x minus 2, is equal to 0. Or option 2, the second number is equal to 0. X minus 6 is equal to 0. There's our second option. Let's deal with them one at a time. In the first case, if x minus 2 is 0, we have some number, we take away 2, we get 0. The sum number must be 2. So there is one possibility for the value of x. Or maybe the second option is true. Some number take away 6 gives us 0. The sum number must be 6. And there is the second possibility for our value of x. Which one of those is the correct value? Which one of those is the true solution? Well, again, we don't know. Without more context, we have no way of picking one over the other. They are both possibilities. If we had some more context, maybe we could eliminate one, or maybe definitely say yes to one. Without that extra context, without knowing something about the x that we're never going to find out in this question, without knowing something about it, we can't be sure which one is the correct value, so we offer them up as two possible answers. So we can say then that x is equal to 2 or 6. If we got some more context, we might be able to pick one or the other, but as it is for now, we've got two possible values. And in a couple of lessons' time, I will be able to show you a picture that properly explains why there are two possible values. For now, we just have to take it that there are two possible values until we have some extra context that lets us eliminate one of them.